Hello fellow problem solvers. So today we're going to be doing a problem that's a pretty cool sequence number theory problem, which I invite you to try out for a minimum of 30 minutes, ideally an hour to an hour and a half, maybe an hour, 45 minutes, but not more than 2.5 hours. I've actually tried to solve this problem before this video. I didn't have the solution. And I must say, I so really want you to try and solve this problem because it has a very important principle in problem solving in general that you can learn by trying to solve this problem, especially with sequences like this. So without further ado, let's begin. What do we have? We have a sequence defined by x1 is equal to 4, x2 is equal to 6. Okay, so it starts from like a little bit, these integers which are a bit bigger than say 1 or 2, and let xn be the smallest composite integer greater than 2 times xn minus 1 minus xn minus 2. Okay, that's a very interesting definition of a sequence, right? It doesn't just have the next one in terms of the other two, but has this like strange what if 2xn minus 1 minus xn minus 2 plus 1 is a prime. There's like this sort of edge case where you're like, whoa, what's going to happen there? Oh, we don't know. And the question is determine x 2022. You can determine x 2023, x 2024, depending on when you watch this video. So this is the problem. And at first glance, what are your first ideas, right? Stop for 5 to 10 minutes and put your first ideas out on paper. And here are my first ideas. I don't have any. I have none. It's like, how do I figure out whether this plus 1 is composite or not? And maybe the first idea is, well, sometimes we could have, like the problem is, if this is even, then we have an issue. And it's even if xn minus 2 is even, right? If xn minus 2 is odd, we know that the next sort of composite integer, smallest composite integer greater than this will be 2xn minus 1 minus 2xn minus 2. So if this is even, we're good. If it's not, then what if this plus 1 is a prime? And the thing is, for me, when I was trying to solve this, I had zero clue how to do it. So what did I do? I played around with small cases, which here means I wrote out the first couple of members of the sequence. And that's what I invite you to do now for the next 10 to 15 minutes. And here are the next couple of members. And we have these first members of the sequence. And we see, okay, so we have 9, 14, 20, 27, 35, 44, 54, 65, 77, 90, 104, and 119. Now, the evens here aren't that interesting. What is interesting here is when I was writing down these sorts of next members, and I'm calculating this, I saw, wait a second, this is just like xn minus 1 plus the difference between these two members. And why am I looking at the difference? Well, because it's increasing. Right here, we have from the condition that sort of xn minus 1 is going to be greater than or equal to xn minus 1 minus xn minus 2 plus 1. Right? Because it cannot be equal to that. Right? Xn can't be equal to that. It's greater than or equal to that. And so when you add 1, it's at least that. And it seems like it will be somewhat tractable if you add a 1. Like, mind you, here we're either adding, the difference either increases by 1, 2. Can it increase by 3? No, it can't. It either increases by 1 every time or by 2 every time. And here we saw that we came across a couple of these numbers where it's increasing quite nicely, right? It's plus 5, plus 6, 7, 8, 9, 10, 11, 12. And the odd numbers that we're getting are kind of nice, right? This is, I mean, actually, no, they're not kind of nice. On first glance, this is 5 times 7. Okay, then 5 times 13. Okay, so it's going to be divisibility by 5. But then we run into 119. And for a second you think, oh no, 119 isn't prime. Then you realize 7 times 17 is 7 times 10 plus 7 times 7, which is 70 plus 49, 119. So we are good. Now, can we sort of guess what this sequence is going to look like? And the answer is, I invite you to pause for 5-10 minutes and guess it. Because here's what it looks like once you do these sorts of now manipulations. If we're guessing what the sequence is, and then we're going to prove that it's in fact that. Here's what that is. So this is what it would look like. Like we would have x3 is equal to 9, sort of the starting, and then we have what xn would be xn minus 1 plus what do we have? N minus 1. So if it's 20, we add if it's a 5, we add a 7. So this is n plus 1. And then the formula would look like da 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 da. We're adding all the way till 3. And that ends up giving us n times n plus 3 over 2 as the general formula for the sequence. And now we don't really have to. Now how do we prove that this is in fact the general formula? We do this by induction. Assume this is true for n and n minus 1. For some n, we know that it is in fact true for n1 through, for n3 through, what is this? 11, 12, 13, 14, through 14. So it's true for n is less than or equal to 14 and greater than or equal to 3. That is true. And now we prove that it is in fact true for, assume it's true for some k, such that xk minus 1 and xk minus 2, this is equal to, according to this formula, k minus 1 times, so k minus 1 plus 3 is k plus 2 over 2, and this is going to be equal to k minus 2 times k plus 1 over 2. Now twice this minus this then becomes equal to, it's equal to this, it's equal to k squared plus 3k minus 2 over 2. And that, well, that simplifies nicely as k squared plus 3k over 2 minus 1. And then our integer, the xk, is defined as the smallest composite integer that's greater than this. Now, given that k squared plus 3k over 2 is composite because it's a product of k times k plus 3 over 2. It's a product of two integers greater than 1, right? One of these is even, and that over 2 is again greater than 1. It's a product of two integers, yeah, greater than 1. So this is not prime, so this is our composite number. And then we know that this is, in fact, xk. So now we've proved the inductive step. By induction, this is xk for every k. That's greater than or equal to 3. And now with that, we have x of 2022 is going to be equal to 2022 over 2 is going to be 1011 times 2025. What is this equal to? I do not know. Let's do the magic thing. And we get this is 2,047,275, if my calculations were correct. And this finishes up our problem. I like the problem because at the beginning it sounds scary. Like, how do I find composite? How do I prove that this plus 1 isn't a prime? It seems difficult because you're going to run into odd numbers. The idea then is, okay, I maybe should be able to have some sort of general form. And it's roughly of n squared over 2, because I'm roughly adding the next number, right? I'm roughly adding plus 6, plus 7, plus 8. Like, here's the only place where we have this like jump. It's plus 3 and then it's plus 5. I like this problem because you need to write out a couple of examples to get a sense of the general formula. In fact, for me, when I was trying to do this problem, I made a mistake initially thinking that x6 was 25. And that just made the example, like, it still works out late. Like, after, if you define x6 as 25, x5 as 20, if these are like your first two members of the sequence, and the same rule holds, then you will again run into, after some time, that this sequence actually just looks like this. And I'm curious, actually, if given any two inputs, the sequence eventually contains numbers of that eventually you could have it be of this sort of form in the formula? I think it's an interesting question to think about. And this finishes up our problem. Cool little problem. And as always, thanks for problem solving.